Hello, welcome back to Beneficial LIVENODING. In this episode, we're gonna take a look at these nodes in SphereChalk add-on. That's basically can tell you whether the points is inside the volume of mesh or outside the volume of mesh. And can be something that's very useful if you want to kind of scatter some points inside an object. So let's take a look. I just started Blender. Okay, let's select A, delete everything, X delete, and X delete. Oh, yep. And create new node 3. It stuttered a little bit just now. Let's get a point inside mesh. So this is the node. Basically, you provide it with a bunch of points and then some kind of 3D objects, and it's gonna give you mask and the vertices that's actually inside the mesh. So yeah, let's take a look. Maybe we start with P, vector P, to scatter some points. There you go. Viewer draw. Let's take a look. So by default, this will generate some points. Let's make it 5 by 5 by 5 unit size. And let's create a torus. And plug the torus into this guy. And just check out the outline. So I believe we need just to plug this guy in there and the points in there, and as a result we should get the the points being kind of filtered out. So this is our objects, and this is the result. Let's turn off the points here, and let's see. I think the points is it's not showing. So there is the mask right here. There's a vertices. So maybe I need to use like least masking. Vertex mask vertices, and plug this guy in like so. Okay, now it seems to be working. Let me check. Probably need to increase the size of the points. Okay, there you go. We got some scattering inside the torus. So it's a little bit slow. Maybe it's my computer. Okay, cool. So yeah, you can basically use this together with the Voronoi nodes. So I'm gonna save this real quick. SV scatter point volume. Let's try this. I'll reduce the points number and use a script node light, and let's get the Voronoi 3D. So with Voronoi 3D, we want to have the original original torus, and then we plug in the vertices that's inside the torus, and we should now get the Voronoi for this guy. Okay, cool. Now it is working. We can turn on the shading. There you go. So we can make the shrink to 1 to give like a full object, and point, let's give it like a 0.85. Now you have objects with crack, Voronoi cracking, and this actually works for any 3D objects, but you just need to make sure that the points being scattered is kind of fit the bounding box of this torus. So if we use like a bounding box, it's gonna look something like this. So it's a good idea to actually scatter some points inside the bounding box first, and before we further set this up. So the scatter inside the 3D volume, this is how you do it. So that's the bounding box. Supposedly this vector P field scatter is fitting the objects here. That's why you don't have like too many objects being, you don't have too many points being removed, because originally I think the points here is quite a lot already, so it's 1000 points, but you're gonna remove some points. See, that's the original points. If we fit this a little bit better, like maybe 4, we're gonna have more points inside the torus, and that means like more Voronoi crack. Let me try randomizing the seed. Yeah, see, the crack is actually happening. Let me turn that off. So yeah, this is like the whole nodes, like the whole bunch of nodes that you want to use if you want to generate a 3D Voronoi crack only inside the mesh. Okay, there's some kind of glitch there. Let me try randomize the seed further. There you go, that's a nicer result. I can just bake it and get all the Voronoi crack, and it is still like a single object. So sometimes you might see like a weird things happening. That's because the points are outside, I guess. But anyhow, this is like I think that's a good start. So thanks to this points inside mesh, you can generate this kind of thing without needing to use the particle system. Yeah, very powerful, but I'll investigate a little bit more. I think I need to fit this vector P inside this bounding box and then plug this into point inside mesh, and we should get a better result, I guess. So yeah, still like it's gonna take a bit of time of investigating, so I guess I'll see you in the next video. Thanks again.